Yeah, you better start heading down there about 6 o'clock, 6:15. All right. So the question we got is right here. Mr. Michelle sent this question. Let's see which one. This is 17. So we'll start with that one. This is 17 in the book, number 7 online. I hope it's if it's not a decent question, I'm going to just make one up. See the data set. Okay, that's good. I don't mind that. All right, so I want you to write those down. Well, I'll go ahead and do it in the spreadsheet, and you be punching them in your calculator. If you want to do them in the spreadsheet, that's fine. I don't mind. Let me get this minimized and get this minimized and bring in the handy dandy calculator. I'm supposed to be getting my Smart View reinstalled right after this class. So hopefully we can do away with this calculator and my Smart View is a whole lot bigger. I don't know if y'all are familiar with TI Smart View. It basically puts this screen over on the right-hand side and you have the whole left-hand side for the keyboard. And it's better for y'all as students, but I don't know. Some of y'all may not like it. Some of y'all may complain about it. Somebody always does. I ask y'all to interact, and y'all won't say anything, but y'all will complain. Okay, so here we go. If first thing you do is draw a scatter plot. So you highlight those 2 columns. You go to Insert. You go over to where it says Charts, and you see different kind of charts. Go to the scatter plot chart and pull down the menu and click on scatter plot. So that's how you do it on the Excel spreadsheet. Now, once you get the scatter plot, right click on one of the dots, it doesn't matter which one, and go down to add trend line. And it asks you what kind, and most of these that we're going to be doing are linear. So just leave it on linear and go down and hit display equation and display R squared. And X out of that. Oh, display equation and display R squared and X out of that. And there is your equation as well as your R squared. Now, we don't want R squared. What do we want?
R.
We want R, Hubert. Yeah, so what are you going to do to get R?
Unsquare it.
Take the square root or raise it to the 0.5 power. So that's going to be 0.8556 raised to the 0.5 power. And don't ask me why a sophisticated spreadsheet like Excel would not give you the correlation coefficient. I don't know. But anyway, there it is, 0.92. So I'll highlight that in yellow or green. And hopefully, Mr. Michelle, that will answer your question as far as Excel goes. Does that help out?
Yes, sir. Whenever
we'll go over it again, don't worry. What?
Whenever I went to go type it in, I believe that's what I got, and it said it was incorrect.
Okay, well, first of all, you don't have to type it in Excel. You just do the little sheet. Hold on. You do the little thing right here, and it copies, it opens in Excel. And that way you don't have to type them in.
Oh, okay.
So that would save you a whole lot of time. Okay?
Yes, sir.
All right. So let's do it in the calculator. So pull up the handy dandy calculator. Let me clear out anything that's in that one.
You have a work email.
They're gonna be emailing me because they're gonna remote onto my computer at 11. So, all right. So we're gonna type in our numbers. Hit Stat, Edit, and I'm gonna clear my L1. You don't have to, but I am. And here we go. 2, 4, 6, 6, 7. 2, 4, 6, 6, 7. And next column, 4, 8, 11, 12, 19. 4, 8, 11, 12, 19. Everybody good?
Yes, sir.
All right, so you have to do the calculator in different steps. All right, so just you can do them whichever steps you want to. I'm going to plot mine first. So I go to second, y is equal. What's above y is equal in blue? Stat plot. So that's why you hit the second button and y is equal. Hit number 1, just hit enter. It's already in number 1. You can go, I don't know why you'd want to go to number 3 and 4 unless you just got a bunch of different plots. I always use 1. So hit enter. Make sure that you got to turn it on. Hit enter. And it's automatically defaulted to a scatter plot. And it automatically defaults to L1 and L2. So all that you have to do then is hit graph. Now, of course, you don't see but 2 points. So what do? You quit. No, you hit zoom 9. 9 is stat. There you go. And there is your 1, 2, 3, 4, 5. And you see these 2 points are distinct. This is the line right here pretty much. These 2 points are below that line. So on the handy dandy question, you're looking for 2 points below the line. And I think that would be this one. Yep, that's right. Now, on the calculator, how do you find the least square regression or the line of best fit? You go to stat, go to calculate, and go to linear what? Regression. It's already defaulted to L1 and L2, and you hit calculate. Now, let me go ahead and talk to you about this because I want you to see that you're not crazy. I remember me telling you that the probability of statistics people, whoever started it, they wanted to make things different because they didn't want to be associated with mathematics and algebra. So they changed a lot of things. You have been studying all your life that algebra, the general form of a line, somebody turned on their video for about a second. Dang, gummit. You can turn it back on if you want to. All right, y is equal to mx plus b. You've been taught that for the last 3 years of algebra, pre-algebra, algebra 1, algebra 2, pre-cal. You've been taught that. And then lo and behold, what do they do in probability? They change the M to an A. And to this day, I don't know why they do that. Only to make things difficult. So I'm not going to call it that. I'm going to call it y is equal to mx plus b. And in this case, M is equal to 2.5625, and B is equal to negative 2.0125, and R is equal to 0.9249636845. And those are the 3 numbers you need. Now you can take this, plug and chug, and you get y is equal to 2.5625x minus 2.0125. And that should be what they got right here. And of course, R is 0.9249, 0.9249. Now, how do you draw that on the calculator? Well, you take your handy dandy y equals button and you type in 2.5625x minus 2.0125 and graph. It's a miracle. There you go. And now you've got 2 resources to do this problem. Mr. Michelle, does that help you out? We're going to go over another one.
Yes, sir.
All right?
Thank
Any
you.
questions? How's everybody feel? Remember, if you don't talk to me, I'm going to keep on going, so you better say something.
How do you find it?
Go ahead.
You can go ahead.
Okay, let's see who that is. I got to find you first. Hold on. That
was
is Miss
me.
Garcia. Miss Garcia, what's your question?
I think I sent in a question for
Okay.
I sent in 2, and
Okay.
my second question, the latest one, it was I don't quite remember it, but it had to do
Okay.
with R. You had to find R, and then you had to find, I think, a critical number or
Yeah,
something.
and that's really kind of, it's really not, I'm gonna show you how to do it. Yeah,
Okay.
let's go ahead and go back to the question because let's get that out of the way.
Um,
Go ahead. How many numbers do we have in our data set? 1, 2, 3, 4, 5. You got 5 points. Everybody understand that? 1, 2, 3, 4, 5. So n is equal to 5. So you go to your critical value and find n is equal to 5. So you've got to have at least a 0.878 R for this to be valid. Does everybody understand that? That 0.878 is kind of like in theory. In theory, you have 5 points. You should have R is equal to at least 0.878. What do we have? Let's go back. We have R is equal to what? 0.925. 0.92 what? 0.925. And that's way above the critical value. So down here, we're going to say the correlation coefficient is 0.925. And that means that we're doing good because, here it is, because the correlation coefficient is positive and the absolute value of the correlation coefficient is 0.925, is greater than the critical value of, what was it, 0.878? Somebody remember that?
878.
878. A positive linear relation exists. So write that down. That's what you're going to put. Now, if the line's going negative, then you would say negative. Okay, you would say negative. And then you would say, and the absolute value is whatever the absolute value is of. If you had a negative 9.925, then you would put 0.925 here. And then you would say, and then you would compare it to the critical value. And if it's less than, then you would have a negative. But since this is greater than, you'd have a positive. I think that's what you were asking, right, Ms. Garcia?
Yes, that's what it is.
Okay, so just if we can get a negative, let's see if we can get a question with a negative. I'm gonna check Mr. Michelle's and then I'm gonna do yours. And I don't mind doing these today because that's what I was gonna do. I was gonna show y'all how to find, well, if I didn't cover it before, I was gonna show you how to find R and all that good stuff. So let's go. Yes.
I put 0.925 in for the absolute value and it says it's incorrect.
Well, it didn't on mine.
Well, it does for me.
What does yours say? You might have different values.
I don't think so because everything else is exactly the same.
Okay, check them right quick and make sure one of these numbers isn't different.
Okay.
They may change just one X. There has to be something different because I got this one right.
Yeah, they changed one number.
See, they got you, Miss Macagina.
So
They got you.
how do you find the absolute value again?
Well, you got to find your R. Punch those numbers in. Which number is different?
Oh, I see.
Which number is different?
My R was different too, so I need to put my R in instead of yours.
Okay.
Okay, I'm sorry.
Okay, Miss McGean is drunk this morning. Y'all excuse her. We need to have a class intervention. That's what we need to have. She's back on the sauce. All right, next question. Any other questions on that one? All right, that was number 17. This is number 27, and then I think those are Miss Garcia's right here, so we'll check those afterwards. So this is number 27, number 10. We did number 7. Now we're doing number 10 in your homework. And these are the exact same questions I would ask you on the test. So that's a good thing. Now this is going to be a little bit different. Got a little bit bigger numbers. So I'm going to just copy them. I'm going to go straight to the Excel spreadsheet. And you should be typing them in as I go through the Excel spreadsheet. Hold on. There we go.
You have a work email.
I'm going to get 3 or 4 of those right before 11 o'clock. She's like my daughter. My daughter does that. Before she comes to the house, she texts me like 5 times. And I'm like, why you got to text me 5 times when you're on your way to the house? Why do y'all do that? It's this younger generation. The one that wants to start a revolution but can't make a ham sandwich. There you go. All right, put those in the calculator or do the spreadsheet, whichever one you're using.
Gmail.
Can you do the spreadsheet again and show us how?
Yeah, I'm going to do both. I'm going to do the spreadsheet and I'm going to do the I'm sorry. I was making sure IE ain't going to come up on me and slip up 5 minutes before class. They do that. Kind of like the government agencies, when you're building a house or something, they say they're going to be out there at 11 o'clock and they show up at like 9:30. Well, I want to make sure that mine don't. I meant that the IT department don't do that. Okay, so here we go. And I'm going to take my handy dandy calculator. I'm going to go ahead and type them in. But first, I'm going to clear my y is equal. And I'm going to clear my stat plot. I meant my stat. So edit. I'm going to clear out L1 and L2. And this is just me. I'm just weird. I don't like to. There we go. All right. So 27.5. 25.75. 26. 25.25, 27.25, 26.25, sorry, hold on, 26.25, 26.25, and 27.25. And now we're going to the top of the next column. And 17.3, 17.1, 17.2, 17.1, 17.5, 17.2, 17.2, and 17.4. Everybody good? All right, so since the Excel spreadsheet is a little bit bigger and y'all can see a little bit more, I'm going to do it first. So I'm going to highlight those 2 sets of numbers. I'm going to go to Insert. I'm going to go over to Chart Plot, scroll down menu, and hit the scatter plot. Make it bigger if you want to. I'm going to do that so y'all can see it. Oh, just cooperate. All right, I'm going to right click on one of the dots and add trend line. Go down to display and display and X out of that. And there is my information. So R is equal to, R is equal to, and that's supposed to be a lowercase r. That's an error, but it's Excel and I'm not going to complain about it. I mean, after all, Bill Gates thinks he's a doctor and a vaccination person. So anyway, 0.7619 raised to the what? 0.5 power. So there is our R, and I highlight that green so that you'll know that that's what you need to find.
Mr. McGuire.
Any questions? Yes.
I just did a homework problem just like this. It wasn't the same one, but I did all that, and I squared my R, and I put the answer in, and it says it's not right.
You squared it. You're not supposed to square it. You're supposed to take the 0.5 power.
I mean, sorry.
0.5.
You mean like... I'm horrible.
Yeah, you probably raised it to the second power.
No, I didn't. I didn't do that. I took the second power off of it.
Okay, then you need to raise it to the 0.5 power.
Okay, isn't that the same thing as putting like the square symbol
That's
over
the
it?
same thing as the square root, yes.
Okay, well, okay, yeah, I took the square root of it, and it didn't give me the right answer.
Okay, well, you need to send it to me, and we'll do it.
Okay.
All right, so there's our number there. There's our number there. Let's check it with the, and also check it with your calculator, Miss Macagina. Check it with your calculator. Go to Stat, Calculate, Linear Regression. Everything's already defaulted unless you use another column. And there it is. 0.87287, 0.87287. 0.1523, 0.1523. Well, they raised it to 4 because of the 8. And 13.22, 13.22. So everything checks. Let's check the chart plot. Second, stat plot. Plot on, hit enter, and hit graph. Can't see it? Hit zoom 9. There's your plot. Now I'm going to y is equal, and I'm going to type in 0.51.1524 x plus 13.221 and graph. And there is the same thing that we get with the plot right there. Okay, so let's go to the handy dandy question. And let's see, you got that right. R is equal to, let's see what we got. R is equal to 0.873. 0.873. And we need to look at their critical values. How many we got? 1, 2, 3, 4, 5, 6, 7, 8. So N is equal to 8. Needs to be 0.707. We're way above that. So, and let's see, you'd have to fill in. There is, what does this say right here? Does a linear exist? Yes. Look at the graph. Yes, there's a correlation right there. It may not be, it's around 0.87. Now that's 87 cents out of $1. So yeah, there's a correlation there, and it's higher than the critical value, 0.708. So we've got a positive correlation. So that's what you're going to say. Let's go back. Yes, it's either going to be, if I could get this to show in the right, there we go. It's either Bravo or Charlie. So let's see. Is greater than the critical value, and the absolute value of the correlation coefficient is greater. I'm trying to read the question. It's not negative, it's positive. So
How do you
it's
find
greater
that?
than the critical value, 0.707. Was it 707?
I don't understand the critical value.
I'm sorry, say again.
I don't understand the critical value. How do you
Right
find
here,
that?
critical values right there. You just hit the table and find the 8, and it's 0.707. It's a measure. It's a benchmark.
But why
In
is
other
it?
words, you compare your R value to that critical value. And
But how
since
do
this
you-
one, since our R value is 0.94, it's greater than that, so we have a positive correlation. You understand?
So how is it supposed to? How do you know it's supposed to be 8 though instead of like 10 or 5?
How many points do we have? That's what I counted the points. 1, 2, 3, 4, 5, 6, 7, 8. There's 8
Okay,
points.
I see.
Okay?
Okay, I see.
Okay, convert the, okay, this doesn't matter. I'm not going to do this because it doesn't change anything. Let me ask you something. If your foot, okay, Mr. Michelle, you sent this question. If your foot is
Yes.
12 inches long
Priority 1 message coming in on secured
and you
channel.
measure it by centimeters, is centimeters going to change anything as far as the R value or anything like that? Or is it going to be the same values?
Priority 1 message coming in
Oh,
on
my
secured
Lord.
Should
channel.
be the same.
They'd be the same.
It
So what
should-
they're trying to get you to see is, I'm turning my phone on vibrate. I'm sorry. Hold on. I didn't know people were going to blow. I know what it is. Hold on just a second.
I
I
put
wanted to check and see. I have a feeling. Yeah, my 103 class is actually sending me homework questions. Good. Yeah. All right, let's go to the next question. Yes, who's got a question?
me. I put in the critical value and it says it's not correct.
Okay, you got to show me what you sending me. I don't know what you're doing. Send it to me.
Okay, I was doing the same problem we just did.
You're not doing the same problem. You can't be, because this is Mr. Michelle's problem. His problem is going to be different from yours.
But
You got
when
to
I
check
looked,
it.
but when I looked at the critical value table and went to the 8, it has the same number that y'all
They're
do.
going to be the same, but these numbers over here are not going to be the same as yours.
So then I don't think I understand how to find the critical value.
Okay, how many points do you have on your graph?
Let me see. Hang on. 1, 2, 3, 4, 8.
So you go to your critical value and you look under 8.
That's what I did, and I put it in, and it's wrong.
And all of those are going to be right. 0.707.
This
Okay,
one
now
I put in, and it says it's wrong.
Did you put it in right here?
Yep.
Did you hit yes, the variables, or did you hit the one that says yes, the variables are positive? You got to, there's different word here, negative and positive.
Let me see.
Ours is positive because it's greater than.
Let me see. Hang on a minute. Oh, okay. I hit the wrong one.
That's all right.
Okay, sorry. No, I got it. Yeah, okay. Now it's right.
Got it?
Yeah, I'm
All right.
sorry.
That's all right. It's better than you sitting there going, like 80% of the class does. I mean, it wasn't for 2 or 3 people in this class, it would be like Patrick Starfish. All right, so let's do another one. Okay, that takes care of that one. Mr. Michelle, you good on those 2? You done went
Yes,
back to
sir.
sleep. All right.
Yes, sir.
Can you do
Okay,
the
Miss
question?
Garcia, how you feel about yours? Does that help?
I'm better on mine, yeah.
Okay, let me go up here. Let's see what this one is. Since she kept getting the wrong answer, let's see. Since it's the same type question, this is number 8. So I've done 8, 10, and 14 or something like that. So here's another one. Miss Dennis is missing class. She must have had to work. Yeah, they're doing vaccines. Okay. She's telling me that she had to do vaccines today. So that's why she's not in class. All right, here we go. Here's the data set. And I'm going to go to Excel. I want y'all to type them in your calculator. As soon as it comes up, hold on. There it goes. I'll make it bigger for you. Let me get it over here to the side. Type those in. Pull up my handy dandy calculator. I'm going to go ahead and clear everything. Edit, clear, enter. Edit, clear, enter. And 26179. 26179. And 82695. 82695. 8675309. All right. That's a song in the 80s. Some of y'all don't know, but all right.
Who doesn't know that song? That's a good song.
Oh, the 80s were the best. Besides the 60s, the 80s was the best next to the 60s. After that, there's never been any other good decade of music. Sorry, there's not. I'm sorry. Insert. And there is my, ooh, looks like hardly any correlation here. Let's see what it is. Add trend line. Oh, we got a negative correlation. Somebody tell me why we have a negative correlation. Because the little car is going left to right downward. So we've got a negative correlation. And what else? And what else tells us that? Somebody tell me. What else tells me that we have a negative correlation? We have a negative what?
Slope.
We have a negative slope. So we have a negative correlation and we have a negative slope. Okay, so write it down. Everybody write it down. Write down the numbers. I'm going to go over here and find it. I'm going to hit stat, calculate, linear regression. Everything is there, and there it is. R is negative 0.21. Let's take the square root here. R is equal to, and that's equal to 0.0464 raised to the 0.5 power. And why am I going to put a negative on? Somebody tell me why I'm going to put a negative on it. Because slope is negative. So I'm going to write down here, I'm going to say R is equal to, and then I'm going to put negative, that number right there. And this is my R. Now, somebody tell me why did I do that? Because the slope is what?
Negative.
Slope is negative. There, good job. Thank you, Mr. Michelle. Remember the first thing I told y'all, there is a relationship between the correlation and the slope. And what is that relationship? The sine here. That's right. Yes, the sine. If the slope is negative, R is going to be negative. If the slope is positive, R is going to be positive. And the calculator even does it for you. It says right here, R is negative, dummy. So that's what it says. All right. So what else? Let's graph it. So second, start plot. And go down to everything's on, hit on. and graph. And zoom 9. And y is equal to negative 0.1739 x plus 0.68, I'm sorry, 6.8696. And graph. And there it goes. And then you match that up and this up with the calculator. I meant the question. Done. And looks like that. And the correlation coefficient around the 3 places is negative, hold on, negative 215. And we feel good about ourselves. Now, how many points do we have? Let's see, 1, 2, 3, 4, 5. So n is equal to what? N is equal to 5. Write that down, 0.878. 0.878. Everybody with me?
Mm-hmm.
Okay, so
Yes.
0.878. Because the correlation coefficient is negative, and the absolute value of let's go look at it again. What is the absolute value of 0.215? 215, Hubert. Thank you, class. So 0.215 is not greater than the critical value of 708?
Yes, sir.
Oh my Lord. 708. A negative linear because it is not greater. It is below the 708. Oops, I got it wrong. Because the correlation coefficient.
I think it was 707.
Oh,
My bad.
no. Let's see what I got wrong. What did I get wrong? Oh, I didn't punch the. Wait a minute. Oh, there it is. We got the wrong one altogether. I said 707. It was 878. I'm sorry. That's a problem going back and forth screens. No. I disagree with that. We have a negative correlation there. But I don't understand how they get. I'm going to have to look that up. And we're going to have to stop. Let me look this one up, Miss Macagina, and find out, because evidently I'm missing something here, because we see there is a negative correlation right there. That is a negative correlation, and that is not 0. 0 is no correlation. So I need to do some research on that and find out why they're doing that. All right, let's go ahead and take the roll right quick and cut off the recording, because I need to be out of here.